Okay, let's take a look at some trig ratios. So let's draw a graph. Now it's perfect in the notes, but I'm just going to not draw it perfectly so I don't waste so much space. So we're going to take the x-axis right here and the x-axis and the y-axis right here. And we're going to put a point on the graph. And we're going to put the point -4, 3. So I'm going to count it up perfectly. -4, 3. Now I'm going to draw a vertical line to the x-axis. A vertical line to the x-axis to match our bow tie. And then we're going to draw a hypotenuse to the center, 0, 0, the origin. Now, what are the lengths of the sides of these triangles? Well, we can see that in the graph paper. We know that the height, the y value is 3, and the horizontal length, the x value is 4. Now, I argued that this length is 4, and I'm labeling lengths of a triangle. Some teachers want you to put the negative there. I would rather let ASTC determine all my positives and negatives and do positive triangles. So you get to decide if you want to follow a teacher who uses a negative or label it as a positive length. I'll let you decide. Okay, so we have to do Pythag to get the third side. So a squared plus b squared equals c squared. Are you kidding me? Go back to grade 8 and learn about Pythag. C equals 5. Circle your answer. Put it in the diagram. Circle your answer. Okay, so we have side lengths of 3, 5, and 4. Well, let's give all the ratios. So, what is sine theta equal to? Well, we know SOHCAHTOA, and sine is opposite over hypotenuse. So first of all, where's theta? I'm going to identify it in the diagram. Remember, it's the triangle. It's the angle inside the triangle, hugging the x-axis inside your bow tie. So there's theta. So I'm going to label my diagram. We have adjacent to theta, we have opposite of theta, and we have the hypotenuse, the 5. So my sine ratio will therefore be opposite 3. No, excuse me, I'm going to write my 3 definitions first. Sine theta equals, cos theta equals, tan theta equals. And I'm going to do what I said I did from the last section. I'm going to ASTC my graph. A, S, T, C. In that order. A, S, T, C. Quadrant. 1, 2, 3, 4. A, S, T, C. So, based on our ASTC, we're in the S quadrant. So we know off to the right, sine is positive and cos is negative and tan is negative. It really helps so you don't have to do so many thought processes. We rarely do mnemonic devices. We've done FOIL back in grade 9 and we've done ASTC. So now that I've gotten the signs out of the way, I can simply substitute into the formulas. Again, sine theta from SOHCAHTOA above is opposite over hypotenuse, which is 3 over 5. Cosine theta, we already know it's negative. Now, I am going with positive 4 for the adjacent side. So, for cos, I just say 4 over 5, adjacent over hypotenuse, ka. But if you are going to call it a -4 length, then you have to call it -4 over 5 and completely disregard ASTC, but no overlapping the rules. So tan theta, we already know it's negative because it's in the S quadrant where only sine is positive. And tan, TOA, is opposite 3 over adjacent 4. Okay, so now remember we can do the inverse calculation to find the angle. So I've done it off to the right in the notes because I've actually had some space. So I'm just going to shrink this stuff, and I hope you're writing smaller than I am. So I'm going to use tan just for fun. So, you know what? I'm going to do it down the page because it's actually prettier. I'm surprised. Oh, I know why I went to the right, because I didn't have any space. Haha. Either way, I'm going to use tan. So theta equals tan -1 open bracket Go back to trig in grade 10 if you don't remember this. Finding the angle, we do tan inverse, the second calc button on the calculator. But we inverse the positive value, 3/4. Always the positive. Even if this is negative, we do the positive. We do that so we always get the reference angle. So theta r equals, type into your calculator, second tan 3/4 positive, even though the fraction is negative. And we get 36.9 degrees. Circle your answer. Put it in the diagram where theta is. 36.9 degrees equals theta. Draw big diagrams. So now we have to figure out what theta STP is. So that's going to be from the positive x-axis to wherever our terminal arm is. So let's draw that in the diagram and call it theta STP. And let's find it down below. So theta STP, remember, logic, 180 degrees on a line. Part of it's 36.9. So we just have to do 180 minus 36.9 to get the answer 143.1 degrees. Circle your answer. So now we have the reference angle and theta STP. Now I'm actually going to take our answer and actually put it in the diagram where STP is. So I'm going to write 143.1. Then I'm going to circle that part because it's found information. Circle the 36.9, the other angle as well. It's found information. So we have both angles. And all the sine, cos, and tan ratio from a point. Remembering, either use ASTC or negatives. And when you do the theta inverse, you always do the positive anyways. So that will be an example of a point on a graph. Now, obviously, check our answer. So let's use one of these. Let's use sine. So remember, the little reference angle is the little grade 10 angle to help us do trig. It's STP. It's all about STP. So I have to sine the STP angle that I just got, 143.1, and I get 0.6, which is exactly the same as 3/5, so near the answer in big blue check mark. Making sure you check your answer. It literally does so many things for you. Or do it with a different thing. Okay, a little bit more. Big blue, bottom right-hand corner. Only inverse positives. It always gives you the reference angle. So what I've done in the notes is done 3 examples side by side, inversing the negative and the positive of its respective example directly above and below. And it just shows, if you inverse the positive and the negative, sometimes you get the reference angle, sometimes you get some funny thing, sometimes you get the angle in standard position, sometimes you get some negative something or other, I don't know. And it's a lot of logic. So just remember, inverse the positive, always get the reference angle, put it in the diagram, find out what STP is using angles on a line, add to 180, and either 180 plus or minus or 360 plus or minus. Okay, down below. So let's take a look. In the notes, we've got sine theta equals 0.8. So it says off to the right, solve for theta between 0 and 360 and the general solution. So that funny looking 0 less than theta less than 360 means between 0 and 360. So let's draw a graph between 0 and 360. So usually either 6 horizontal lines, 6 vertical lines, meaning 3 in each direction, or just 2. Now, sine theta is equal to 0.8. It's positive, so I'm going to start thinking about positives and negatives. Oh yeah, ASTC. Let's ASTC our graph, way out in the far corners. Now, sine above, sine is equal to 0.8. That's positive. Where is sine positive? Well, it's positive in the A quadrant and the S quadrant. So we're just going to draw 2 triangles, looking like a bow tie, in the 2 triangles where sine's positive. Now, let's do a little bit of theory off to the right. So we know sine theta is equal to 0.8. Well, we know point's 8 over 1. Oh, interesting. So we could draw a right angle triangle, and the definition of sine theta is opposite 0.8 over hypotenuse 1. Sure. But the fraction above can also be written as 8 over 10. And we could also have a similar triangle with theta and an opposite of 8 and a hypotenuse of 10. Or we could simplify that fraction and have an opposite of 4 and a hypotenuse of 5. They're all similar triangles with the same theta, so it doesn't matter. So I chose 1 and 0.8, and again 1 and 0.8. Now how do we get that angle? Well, we know that sine theta is equal to 0.8. Therefore, theta is equal to the inverse calculation of that. I'm going to put a positive sign to remind myself I thought through the positive thing that we just learned. And we learned it in grade 10. 0.8. Therefore, theta equals... Notice how my equal sign is always in the same spot, and it always looks so perfect and simple to read. It's going to simplify your studying so much in the future either way. So we do the inverse. Notice I did that calculation below the graph in the notes, whatever. And we get 53.1 degrees. And we know that the angle we just found is r, theta r, 53.1. And we can put it in both locations in the diagram. 53.1, 53.1. Put in your right angles if you want to. So those are our reference angles. Those are our fairy tale grade 10 angles to introduce us to trig, to allow us to more easily solve right angle triangles. And in grade 12, we're going to learn how SOHCAHTOA is kind of funny. So now we need to find theta STP. And we know theta STP is an angle from the positive x-axis to the first terminal arm and an angle from the positive x-axis to the second terminal arm. And the first angle is as you see it. So below we've got 53.1 and the other one, 180 minus 53.1, theta STP equals 126.9 degrees. Circle your answer. So we found the reference angle just to find theta STP eventually. Again, theta r is the tiny little angle inside the triangles of the bow tie. And theta STP is the angle from the principal axis to the terminal arm and the other terminal arm, and figure what those are through logic. So, above we saw a point on a graph. And we had one answer, and then we had an equation, and we had two answers. So we have what's called the general solution. And it's actually a coterminal angle formula. And that formula is theta equals, we don't even have a subscript because this is the all-encompassing formula. And it's theta STP. In the notes, it shows Pn. I'm just going to tell you, it's usually plus or minus 360 N. So what is this? What does this mean? Well, we know that the angle can be here, 53.1, or we can add 360 to it, or add 360 to it, or add 360 to it. Or we can be 180 minus 53.1, 126.9. And we can add 360 to it, and add 360 to it, and add 360 to it. So we have what's called a general solution. To understand this better, we can draw a graph. Imagine getting on a Ferris wheel. Imagine getting on a Ferris wheel and being a little dot on that Ferris wheel and going around the Ferris wheel. Can you imagine a triangle following you around the circle, getting bigger and bigger and bigger and bigger, and then going out this way and then get smaller and flatter, then going over here and then getting bigger and bigger, and then going down here and getting smaller and flatter and smaller and flatter? whichever. We can actually graph those over time. So I'm going to switch hands for a second. Watch my right hand be going around the Ferris wheel. And then let's graph it over time. So we're going to go up and around and down. And then over time we have to... Oh, I don't know if I kept doing that properly with my right hand. That's tough. So there's the graph. The graph of sine theta, or y equals sine theta. And for example, in the question that we've been working on, where is sine theta equal to 0.8? Well, we know in the graph in the bottom right-hand corner, sine goes up to 1 and down to -1. And 0.8 is like right here. And it hits it twice. Exactly at the two angles we got. Between 0 and 360. A full rotation. So this graph continues, as you can see in the notes. So it gets solutions far and far in the future, which are answers outside of 360 if they ask you for those. We forgot to check our answer in the last question, but look at the notes, check your answer, check mark. Okay, so let's find this general solution. So theta equals our first STP from above that we were supposed to check, degrees plus or minus 360n. And the other answer, theta equals from above 126.9 degrees plus minus 360n. There's some funny stuff that you write off to the right. Some teachers argue as to what it is. I'll let your teacher decide, any I, any W. But that is our final answer. Every answer in the future. So that was points on a graph and an introduction to equations and a little bit of review from grade 10. And then now putting triangles on a graph and having that terminal arm go around and around and around and getting general solutions. Okay, let's take a look at some more triangles.